Oh, hello guys, and welcome back to yet another amazing stream. I'm your host, TH3Fish, and today we're going to do more programming. Oh, God. And if you don't know, we've been working on some kind of weird binary emulation machine that's like weird. I don't even know what I'm making at this point, but I mean, I'm making something, and it's just a bunch of switches and cases. Very cool, I like it. However, I have something new that I haven't tested yet. It's this new feature right here. Engine.register's address, which should be essentially to take... where does address go? Oh, address equals get bin engine state 8 and 8. So that means it's setting, so obviously you have type, size, instruction. So we go type, size, instruction. And then we go down to the last one, which is get bin engine state, which is going to be 8. And start at 8 with a width of 8. So it'll be like the last 8 before the instruction. And then it will put it into the address that it creates from that. So it has a width of 8. That means your total number of addresses is something like 255. But you can only store a U byte. And I don't really know if we really want that. So like, something interesting, or something that's important, is initialization of different storage as it's needed. For example, you don't want to make like a massive array and have it just be existing in a massive quantity. You don't want that. That's not something you want normally, because... And I'm not sure on this, but wouldn't it make the most sense to initialize a register in here and then... Or to do a ulong, or... Yeah, ulong registers would be a good idea as well. Although it would take a little bit more RAM to do. Because these are going to live in the memory pretty much. It's like RAM and registers and shit. However, the entire purpose of this is to basically hold the potential states that registers can have. So like if we have 64 registers, that's a lot of different potentials to have. And this is for 8-bit ones, so like byte size operations will involve this. So anything in 8-bit territory is going to pretty much just be take this and do that. Or take this and and each thread should be able to... However, one of the ideas that I had was that we should take a uint instead. A uint with 64 is sufficient to hold them. Here's the thing, is that when we initialize that uint for each register, obviously... Or we would keep it as a U byte and just keep it with 255 registers. Well, we could do 256, which is a huge array. And it will, it will just pretty much all of them will be initialized as 0 until we actually set them. And we need them to be able to be set at multiple at once. Like that would be the most optimal, is to set multiple of those. I'm sure I can create an instruction to handle that, but for now we'll just give it a basic testing instruction. Let's keep it back down to 64. Yeah, that'll be good. So no, don't need to DUB. Need a CD to my desktop to my dtools to my other thing, which is what is it? Oh, fish common. And then DMD fish bitwise, or no, fish 64.d fish bitwise .d. All right, now here's the errors. So it needs to actually have this as a ubyte. Now there's a couple ways we can handle this. There's the method that will take there's the technique that will take the less amount of memory, I think, is to use uint and do less. However, that'll take the least CPU performance because we'll have to do as well. We might have to initialize it a bunch. There is no like real array addition. I don't think. You just have to take the elements of an array and then add them together. Like, let's give an example of what I want to do. So in my head, I have an idea for kind of what I want to do. Here, I'll go ahead and illustrate it. So when you're working with 8-bit numbers and you have a 32-bit cap for how many numbers you can, or how many bits you can have, right? The idea that I have is pretty simple. In theory, I have 32 bits, and that does not equal 8, but 8 goes into it a total of 4 times. And so if we have 4 times 8, then, well, we could also try to well, it didn't work well with the ulongs, by the way. So it's right now it's only 32 bits. Eventually I will get it to where it can do 64 bits operations. But anyway, essentially this will end up being almost like a GPU, but like it can only handle really tiny numbers. That's fair enough. But anyway, we have 4. So we can do a set of 4 bytes. Yeah. And then we can do addition operations with those. So my idea is to take that uint, take my 4 bytes, and put it into each place on that uint. Because I think that you can get it way faster with that than you could with another technique. I feel like if we do it this way, we have like our 0, 1, our like, let's say we have F0, C3, I like C3, well, we'll go with 0C, and then A, well, 3A. Right, we have this, and then we also have, 2C 0, 4. Now, obviously, there's some issues because I don't know what these numbers are. Honestly, if you take this in uint, I have no fucking clue what number this is. But you know what I do know is that this is probably, you add them together and it's probably going to overflow more than likely. Or something could go wrong and it's not going to work out too well. That's my only concern with this technique, to increase the amount of processing per operation. So this is one technique I want to implement, but am currently thinking of implementing, because this equals like 4 times your cores. So like if I have 12 cores, now I have 48 cores. But the issue is smaller data and potential overflow. yeah, y'all can get what I mean. I'm getting really angry at this because I suck at that. So the other option I'm looking at is array. We take an array and add ubyte array. So the ubyte array, we initialize our registers as ubyte array, or take slices or some shit like that. But basically, gonna take off the ubyte array and then go, and then have our 4 numbers, right? Now that keeps our data pretty secure against potential overflows. I mean, yes, there's still potential for overflows. You're still limited to 255 for each individual pair. By the way, that's actually a good thing to note, is that in the previous method, adding like FF plus FF is going to give you an overflow and potentially ruin the equation if that's not caught. So that has to be detected, and that would slow it down as well as catching errors like that. Catching an error where you have, like, that other shit. Obviously, we don't want to mess with that. And this is not a good technique either, because this will need you to just for each. And I don't want a for each. I want specifically the maximum efficiency we can get out of this, which is to squeeze the everything into a uint. Like, obviously, yes, we could do this, but uint is probably what we want, especially if we can do 0c and, like, 0a. Like, if you're adding 1 plus 2, that's fine. Adding 100 and 100 is fine, even. Like, if we add 100 and 100, perfect. But going, like, anything past this 255 number is where things are dangerous. So what we'll do to check that is we'll check all of the numbers before they go in, and if they exceed, well, that would mean we'd have to add them before they get in to check that they're not exceeding the 255 bit or 255 number. But yeah, we'd take the bytes, we'd take the bytes and make sure they're not greater than that. I don't want to do that, though. I mean, we can do it. But we could also do that in this case, too. And then just take these and make them into a uint. But anyway, that's just a brief overview of what I'm thinking. What my overall goal is. So registers has no effect. What do you mean registers has no effect? Fish64.d. What is this supposed to be a write ln? Write bin. And let's just go with that. Control S. Alright, let's see. Engine.register to type u parameter uint input. Oh my god. Oh, I know what's going on. So write bin is not callable using argument types ubyte. Fair enough. Write ln, then we'll just write ln there. For the other ones, address, unidentified identifier, that just needs to be classified as a ulong. Actually, no, it's a uint. Did I change the iterator to ulong? So, you know, I actually added an iterator too to simulate computer clocks, because that is a thing that computers have. So we must have a clock in this system as well. That way things can depend on that. And then anytime this program restarts, it will restart the clock too. So if the program exceeds a certain limit, what will happen is that will overflow. So to account for the overflow is that it will hit that point and then it will throw an exception, hopefully. I don't know if it does that by default, but I kind of hope it does. And then once it hits that and overflows, it should be like, oh shit, we've overflowed. And now it's time to go ahead and reset the clock and restart the iteration. Or it will just go back to 0, and I mean, won't be an issue. I think it could go back to 0, but also if things are dependent on that iteration number, that's potentially a problem. So we have to keep that in mind. Identifier address. Oh, right, that's why it's like that. Address. Technically, uint is fine, but we could go with ubyte, since that will technically give us up to 255, I believe, if not more. Okay, that's Shigen. Uint to ubyte. That returns a ubyte? Why does that return a ubyte? In what world did I think that was a great idea? Or a uint? My bad. Let's go down. It should be in this one. Oh, actually, that one pulls that one. What are we doing there? Get bin array? Get bin. And it gives you a uint. Okay. Cast to ubyte. So yeah, all we do is just cast the ubyte from that. So something else to cover in this is that I have realized you can technically take and use a scope exit, or like this shit. This shit exists. I didn't realize this existed, but this is how you make it something happen at the end of your scope. So that's pretty useful. Just like the imports inside of your functions is useful. Although it might increase your file sizes and stuff like that. I have no idea yet. Nobody's told me if that's correct information, that it increases your file sizes or not. To ubyte. Did I put a cast uint? Nope. God damn it. You know, that's great of me to figure that out now. Yeah, so we'll have to do it the other way, using uints and 64 registers instead of having a bunch of those. This would make the most sense since the maximal number size you can work with is going to be 32 bits. Obviously, we will want to have 32-bit registers. What am I thinking? Trying to make 8-bit registers and then we'll have 16-bit registers, and that'd be overcomplicated. Let's just keep it simple, stupid, and do that other thing. Yeah, I can't implicitly cast to ubyte. Oh my god. It's okay. Address should be a ubyte, and then, what the helly? What? Excuse me. Engine.state. Get bin engine.state 0,8 get bin. So that's getting the bin number. Right, LN. Oh, fucking great C#. Fucking eating my soul away. Hate C#, bro. How the hell does it even end up in these episodes, even though we're programming and dealing? Operator overload. Set bin. Oh, this is the set bin for the other thing. So what are we doing? Taking the bin from it, right? Get bin. GIT get bin. Bin. Please. Switch case fall through. Go sheet if intended. Where's that at? That's at D51? D51 Super Fortress. Case 0x01, blah 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 blah. That one returns a default where it returns that. Oh, this one's just not inside of a fucking case. That's why it's doing that. I want to add a function called operation, which will handle, or we'll add a actual string here called current operation, and it's going to be printed at the front of each line. That way it's easier to read the debug logs, and they don't have to write like 6,000 fucking lines. I can just have one that I copy and paste throughout the whole thing. Standardize the fucking line. Not once a U byte. However, this is just the same problem as before. Oh wait, it's here. This is the issue, not the other thing. Engine.registers address. I mean, it would take more memory to do it the other way, and then, but it would then print at the end. String debug, and it's just gotta be a string. Oh, that's not a name you can use. Well, you could do underscore debug. Oh, that's gonna be terrible. Please don't do that. Current state. Yeah, not gonna be confusing at all. Surely I won't get confused later. And instead of doing all that, when we receive different instructions, that will just be, I mean, I guess we can keep that there, but every time it runs through an iteration, at the end, it's going to write the current state. So that will be just engine dot current state, and yeah, it will be formatted something like these. Instead of doing failed write instruction and all that, I mean, yeah, we can do that in the default, but instead we could just say engine.current operation equals that. Failed because of size, which will really simplify things, I think, if it doesn't break stuff. Which it has a high potential of doing, since I've never really thought of doing shit like this in this way. However, this also means that we can implement it in places like here, where it's got this, and it's writing 8-bit operation. We can do that as well. So that gives us the engine current states for those. And now we just gotta figure out the issues here, which has a write line for registers at the end of that. It's a formatting issue. And this one wants a ubyte address, but it should really be working with a uint address. And then DMD fish bitwise, and it has a case fall through at default with a colon. So right here on line 53, yes. Case fall through. Apparently this doesn't accept 0x01. So the case here should go to that, then this, and then a default at the end. And that should be based on instruction, which is here. Technically, I could store that inside of the engine. Shouldn't I just store those inside of the engine and then... I mean, that would mean all I have to do is... That'd make it simpler as well. Technically, yeah, that'd probably make it simpler to put it inside of the engine. Have each of those just be engine dot that. Of course, engine dot what is it doing? Engine dot what is it doing? Instead of doing that, exception caught equals exception caught. There's also like other stuff in dealing. Obviously we talked about a bunch of other shit, but there's like checking things. Oh wait, right here. Is this a... That's where the case probably breaks at. So here we have a break for no reason at case 0x01. Is that there for a reason? Is there a reason this is here? Or is this just a... So here we have that, and there is no... Oh, that is the case 0. Okay, that is correct. That should be there. So that's like the exiting from all of this stuff. And then, of course, case, switch, case, which looks correct. Why is this one not correct? Is the default not? Let's look at a perfect default. There's a break at the end. And yeah. These ones have, this one has return. But this one also has a return. Is this, that's good. That good? Yeah, that's fine. So then, what could it be? Probably this return. I'm thinking it should be a break. Although it was working fine yesterday. Use go to default if intended. Switch case fall through. I think I'm just having one of those brain fart moments and I'm not really sure what's wrong with it. We have that. That's correct. It's inside of the same case as the 0x01 case. Unless it needs all of the other numbers too, but it was working fine yesterday. How is this the last problem we have to solve? Maybe it's a cap or a spelling error. Capitalization error. Default, default, default. I mean, he doesn't have a problem with this. Just this one. Compare and contrast my case to that. Looks like it's right. Like, it doesn't look wrong. I don't understand. Anybody see anything in this? Does this look wrong to anybody? I don't see what's wrong with this. Other than potentially that it needs more cases to fill the potential for... but for now, we're not adding more cases, unless it's absolutely required. Until I'm ready and know what they are gonna be. Unless it's, could be a, Could be something else. Oh, we could also append to the failed instruction. For now, I'll just add some appends while I figure that out. While I contemplate what that could potentially be. I think you can append to a string, so that should work. Okay. Let's try and see what happens when we do this. Okay, fall through still. A semicolon afterwards, what? Maybe it is a case where you need to have all of them. What can instruction be? It can be, well no, you wouldn't I guess maybe it wants a 0x02 with a break in there. Or no, on the other one. For whatever reason it wants this. Unless it's because of these? That would make some sense? Maybe it doesn't like parameters. Oh, you know what it is the lack of a return statement on the end of this. This original case, 0x01. Where am I from? I'm from United States. Case 0x01. Return. So that would be put a break on that. Yeah, that should just get us back to the... Well, actually, I've been using returns on... Well, that's because that's an error, so it just throws an error. That's why it wasn't working. Time / fish 64. I don't really need the engine right. Did it do the correct? Okay, let's try return on this. These are the debug lines as we've talked about. These will help me debug things. Tempting. Red init. Yeah, that's what we'll call that. Reg init. What's D-Lang programming? So it's the D programming language. It's just it's pretty good. It's a systems language. Right now I'm working on some kind of weird computer emulator, which is going to be for my own architecture. I'm going to call it the fish architecture. It's going to be like the worst architecture ever designed, probably. Unfortunately. Alright, so it got to there. It didn't fail the instruction, but it doesn't return to continue the next instruction. We should have a file inside of there that's got pretty much all of the stuff. Where is it at? Fish common. Should be in here. Bin file. Looking for that. Example.txt. Why is there an example.bin? example.txt was for the tutorial? I have no idea what that was. Anyway, I had some issues with it yesterday, getting this thing to work, kind of. Because I was working on it in my own time. So I did a bunch of stuff, like, between... And I covered it at the beginning already, so I'm not going to cover it again, what I did. But, should be, like... This should be a correct... one, and then it's not calling that second instruction because that's too short. So what that means is it just needs another, it needs to be, this is a incorrect instruction actually. 1 0 0 0 0 0. Oh, what the hell? Can only go to that long or something? Let me write another 0 in there. It lets me get rid of zeros. Let me hit the insert key, maybe. Ah, there we go. I got it. Control S. It should execute 2 instructions. Attempt to execute 2 instructions, though. Alright, the first part, this should allow case 1 to be correct. Second part should allow case 2 to be correct. Ignore all the extra zeros. That's just padding. It's really only taking the first 4 of the number. And then for the size, takes the first 4 of these. So this second half byte. And then there's no instruction. Because that's 8. There's 8. Well, it's a full byte for an instruction. And then the rest of it is just 2 8-bit numbers can be contained. Technically, with this one, or with this instruction, I've designed it to be to where you can have the 8 bits specify the address, and then store from there. But this case for switch instruction expects a 0 1 inside of the instruction, and it's going to start by taking... So maybe it's that it doesn't have the instruction placed correctly. Let's check the width of instruction. So instruction is 16 and 8 bits of length, which should put it at 24 for where it ends. But it will be like 1 before 24. So let's look at that again. We put a 0 8 there, but it needs to have a 0 1 in front of that. Save that. That will put it in that first case. Array index 128 is out of bounds for an array of 64, which, because we have a 0, 8, we have 80 there. Obviously, that's not going to work. So we're going to create a 0, 1 again. Which should be, well, technically, F would give us 64, if we want to put it on the 64. That'd be for, like, if you have stack and heap on your registers, like, think of it like that. You can technically make your own stack and heap with this, because then you could be like, well, the highest addresses, that will be my heap, and the lowest addresses will be my stack. I'm pretty sure that's how it works for most, like, OS stuff, but you should correct me if I'm wrong on that. Probably am. One should just default to a case where it breaks and is like, oh, exception caught. And then, of course, we're not going to initialize it as 0. Let's put an FF on that one. So that should be a valid register loading instruction. Exception caught. Oh, it works really good. This is good. So it's an 8-bit operation attempting to load the register. Attempting reg. Or register initialization. Boom. Oh, wait, it actually performs the first instruction correctly. So I need to clean this up because I need to remove that line there. That would help me see it a lot better, but there's a line here that writes out the engine state, write ln engine. We already know that the struct for engine is fine. Theoretically, one of the things you'll be able to do with this program once I'm done with it, if I actually decide to finish it and not just continue with my trend of not actually finishing code, is you'll be able to save this final struct for the engine state so you can reinitialize your engine later, which, I mean, that will allow you to continue over sessions if you create like an operating system on Fish emulator. And that has kind of cleaned things up, except it still writes this line here and doesn't really specify what that it is, so that should be specified, but it is not. It writes that, and then it writes a line there. Oh my gosh. Another write bin for engine state. Oh my, get that out of here. Actually, no, that is correct. So it doesn't actually specify what that is before it does that. We'll just put a write for engine state. Yeah, engine state. Yeah, why not? I want to make these formatted better, so I'm going to capitalize the first letter of each of them just to make it look better. Just engine state type, because that was kind of bothering me, because I feel like some of them are capitalized and then others just aren't. Then we put a semicolon. So engine.state equals the fetch 32 bits from example.bin. Read is the access, and as binary, because you do RB, it's read binary. And this specifies a specific position to read from. So when we go to my bitwise functions, I have this program here, which opens a file called file name and file access, which are up here. And as you see in the function that I have specified file name as example.bin, the access is RB, or read access, and binary to read as binary. And then, oh, my bad. And then ulong for this. And we discussed why that's a ulong earlier. So the reason that I've done this is because that will do, when you do file.seek, every time you iterate, that will increase where you're actually reading code from. So your code can be written inside of the example.bin file, or in my case, that's where I'm writing it. You could redesign it to use a different .bin, and I think eventually I'll have a way to specify that, like load it from a JSON file or from engine state. Potentially you can write it in as the engine state. Although this may get saved as a bin because it's, you might be able to initialize that from JSON, or like serialize it to JSON and from JSON. I'll have to figure out how to do that. I probably could use DUB. It's some stuff from DUB. It's still writing out the entirety of the engine, which really bothers me. So let's figure out why that is. Oh, there's one of these that's 255. Nice. That's exactly what we're expecting. Is for it to read a byte and say, all right, that is the value of that. One of my issues with this is that it takes 64 times 32 bytes, and it's going to have that stored in memory. So that bothers me a lot, even though that's a U byte for 255. But I just want to get specifically a slice maybe of that instead of having it be so like a lot of that. It'd be nice to have just a slice that tells you the number in front and behind it. Maybe like give you 5 numbers of it. And then also would be better if the length, if it just appended it to there, but that wouldn't be great if you're trying to make an operating system or something and you're or like for whatever reason, if you wanted to do that, that would be terrible for that. So, because obviously you need to be able to specify stack and heap, like this be your heap and this be your stack. Let's see. So that placed it at that. It placed it at 1. Technically, if I don't specify an address or in this, it will give me 0. And then let's go ahead and do that same operation here, or 1 1 0 0 0 1, and then 0 0. Technically, I guess I could do 16 bits with this. So this is actually able to handle a 16-bit placement on there. No, because instruction doesn't do anything. The instruction is 0. Am I confused? I think I'm correct. Instruction size should be 0 on that, and then just 1 and FF. We'll do 3 or C3. I like C3. Hello. Welcome. What's up? Okay, it broke again. What did I do this time? Must have screwed something up for sure. So it reads 0 0 1 0 0. Is that correct? It doesn't read the correct instruction on that one. It's got to be 0 1. I'm pretty sure it has to be. Zero. Oh, fucking hell, bro. I'm screwing shit up again. As per usual. There, that should be the 2 instructions. And then we'll have a 1 0 0 0 0 0 0 0, which should just break the program. Alright, let's go ahead and give that a shot. Alright, so it does that and attempts that. It catches an exception on that one. But that makes sense. Because the instruction doesn't grab engine state after the first one, which makes it harder to debug things. So let's go ahead and clean that up. Engine.state equals that, and then it's got write bins. It only does that once though, doesn't it? No, is that in the while loop? Yeah, it's in the for loop actually. It used to be a while loop, and then I switched it to for. The reason I switched to for, that's supposed to be a long actually. I did not change that. Okay, so yeah, that's a long now. Technically it's supposed to be a U long, so it's got like up to 18 billion or some shit. Huge number for that. That's a U long. Okay, they're compatible, so that's good. That's all I'm looking for. Compatibility on those. And then I think we're good from there. Let's try this. Actually. And it also doesn't read the second attempting register initialization, exception caught. Where does it catch the exception? I'm new. Yeah. What's up? Exception caught. : I. Or does that only write I if it makes it through the whole entire for loop? It actually did write the engine state at the end. Oh, I guess it does do that somewhere. Write engine current state, which is exception caught, I colon, or actually, yeah, that's good. That's good. And then puts engine state after. We can, oh, that's gotta be a write bin though. Exactly what that's gotta be. Oh, it's like technically, if I had it write a regular number, it'd just be like 32, and you'd be like, what number is that? What instruction went wrong? Obviously, we don't have every instruction in the system yet. Nor do I have an idea what instruction... I just kind of make instructions based on what I think I need. So it's kind of like... bro, this is like an assembly runtime. Like, what is this language gonna be? Oh my god. So that's fetch bit, and it doesn't initialize another one? No, it does. Type. Oh, it fails on type. Type is 0, 0, 0, 0, 0. But it should have been reading as 0, 1. And also, there's another issue. 0, 1. That's correct. It reads this one correctly. And then it reads these last bytes correctly. Although there might be a bit of an overflow there by one value. Oh my gosh. Kind of a bit of an overflow. What number was that? That's FF. Kind of goes a little bit over where it's supposed to be. 0100C. That's why it goes over, because it's got a 1 there. For whatever reason, I decided to put a 1 there. That might be why the exception's caught. So we'll try that again. I don't know why it doesn't write on the second one what the actual size is. Engine dot registers at address, and then address. Yes, and then current state, and then we also want to write the... actually, if it breaks, then we will write the... just write write ln. Do I have write ln as an import for that main area? For that main scope? Yes, I do. Okay. Write ln, and then this struct is called, like, instruction. I'm new to your channel. I'm watching from Bangladesh. Which country are you from? I'm from the United States. Although my clock says Bangkok right now. It's kind of a joke or something that I have just a random clock time zone. Alright, so then... we have that. What was it? So we have engine state. Oh, we just want to write engine. That'll just give us the whole engine. Which is just a struct called engine, which is initialized at start. So before we do anything, we create this engine struct. Engine contains, and it by default contains a return, even though it doesn't need to anymore. That was a testing thing. I had it contain that. I used to test like that. However, now we can test by writing a program for it in an example.bin. So technically, programs written for it will be written in bin, and then obviously you can write further programs from there that will be able to pull different things. Like if you wanted it to, you could do anything with it, really. That's the idea. It will essentially be a computer, but like not a computer at all. And it's going to be pretty portable. Yeah, so we're looking at that and seeing that's placed at 0, and then it's placing a engine state was the number 1000, a huge number. So it gets to engine state, and it performs that. So it does this, and this, and then it writes out a number 255. So it processed that first instruction, apparently. And then it puts the number 001 on this. Well, actually, that could just be a size thing. Attempting register init, and then it catches the exception. Exception caught 1. So on the second iteration, it caught an exception, and it was this number here. Apparently, that's what it caught. So is it not initializing that next engine state? Like, so it should be writing engine state here. Oh, it's writing engine state there. On the next one. What the formatting is this? You know why it's not writing engine state? Because it's not putting a write line on the attempting register init, and then complete is what it should do. So write that, and then it will write the line for engine state. Well, no, because shouldn't it? Yeah, it should just write that. It should not write that on a new line, but it gets to the bottom where it catches exception. Exception should be a write line, I think. Exception caught. Write ln should be the last thing it does. Pretty sure of that. That should clean it up. Oh, what the hell? Exception caught. So when it writes, where does it write exception caught? Oh, maybe it's because it appends it every time. It should not append that. It should just, well, actually it should. But before it gets there, it needs to write the engine state. Oh. This isn't a problem of write ln, it's a problem of the order of how it does it, and all of that is so strange, kind of, honestly. Because you think about it, it should be, it's just because it hits that engine state at the end, and it's like, yes, we're going to write the exception caught right here. Instead, I think it should set the engine state to exception caught. And then it should, I mean, I guess that's fine. Yeah, just set it to exception caught. Because it will tell you where it's at without that. So yes, engine, exception caught. That's the state. And it starts at the first one, and that's because the number of this is incorrect. Also, what the hell is going on here now? We have 2,500 and that. So the next instruction needs to be on a new line. So we write that. And then we get to the next one. Let's see. So each time it does this, it should just be writing on a new line, right? Scroll down and then find out that, yeah, every time it goes and does this, should be writing on a new line. Technically, I think you can put that function inside of the for loop. Why the hell is it doing that? Okay. Continue to figure out what's wrong with that. Formatting just comes from that. So what exactly are you making? So this is a simulator for an architecture. Basically, I'm just you know, like how I build redstone computers and stuff? It's basically going to be that, but you can run it on your computer instead of having to run it in Minecraft, so it's pretty cool. It's like instructions, basically. It's an instruction runtime, and I'll make a compiler for it eventually, too. So that way you can just compile the code without having to use such a fucking terrible instructions, you know, like you can use fish slang, and then it's basically fish sharp at that point, which will be impressive because that is a programming language on a runtime, and that's the basics of runtime right there. You know what I mean? So now we'll have a high level language that you can run in a really terrible way. Yeah, it's cool, but it's probably not going to work well. It's just kind of a really neat idea, something cool for our project to use bitwise. Since I like bitwise functions, they're quite neat. So in this, what we're looking at right now, what we're trying to fix is that, where does it put bit operation? So it appends bit operation. Where does it append the engine state? Where is it? Write ln. Just put a write ln there, because that will fix that really easily. Maybe the solution to the problem is write ln. Well, actually, I could append that to the engine state. I'm pretty sure I can technically do that. I don't want to try that. It would probably not end up well. So we'll just put a register, and then that's the register stuff done. Pretty nice. So it's got set register to 255. I mean, it doesn't give you the address for the register, obviously. I mean, you don't really need that, but that should be good enough. Obviously, the formatting is kind of a bit annoying too. Like, for example, instruction. We'll just call that inst now. Inst. Put a colon there, because that's 4 letters long, 5 letters long? I guess we can do instr. No. Yeah, we'll do that, actually. We'll try that. No. Same length on all of them, because it looks terrible. Alright, here we go. And it doesn't... Yes, it does write the engine state. Although, it writes the 8-bit operation before it writes the engine state. And we can technically move those down. by padding them out as well. For example, if I just pad these out like a little bit, I'm betting I can get it up to that engine state, and then it will just plop them in there. The only reason they don't do that is because it doesn't... I mean, obviously it's going to change for each one. Yeah, no, we'll go back to the way it was. It was better that way. I should really learn how to use formatted right, because that would be really nice to use to make them the same length. I mean, obviously it works at the start with engine state, but like with the rest of them, nope. It's not going to work because it's going to be changing each time. Obviously you want to be able to compare these. For example, this is just for the first 4. At least you try to make it work. Well, it will work. It's just, will I actually complete this one, or will I go, time to make a new project? I don't really want to keep working on this one because it's a pain in the ass. So that second instruction's what's wrong. Right now, it's catching... It caught the exception, though. It was like... exception. It only loaded the first register. So the exception's caught here, where it tries to perform this. And the reason it's... what it's trying to do is this. This 32-bit number is incorrect. Because... that's just what it is. I'm thinking what it is that the I is not iterating by ×4. The integer iterator is not ×4. That is important, because if it's not ×4, that explains what it's doing. So here we have essentially the same number pattern as you find right here. So it's catching 4 zeros and trying to put it into that slot in the type, doesn't even attempt to put these in there because it finds 4 zeros and goes, that doesn't work, that's a fucking default. Boom, and it defaults it. So that's what's going on. That's why it's broken. That fixed it. Now, there's another issue, is that it appends to engine state every time it does it. So here we have 8-bit operation, 8-bit operation. So to fix that, once it writes that line, clear it. The way you can do that is by setting the length of a line, or a property.length to 0, or just setting the line to equal nothing, or re-equaling the line out on the first one. That can be done inside of the loop, which is up here. This right here will just be a... actually, put it in the engine.current. Engine.current state equals that, which will basically set it to nothing. Now it looks normal again. So that now initializes registers with values, which I think we gave it C3, which is 195. Of course, if it fails, then so be it. So that's a basic register initialization function. The next thing we can try is maybe initializing multiple registers, or initializing a 32-bit number into a register. So for example, that's just to handle the basically a U byte in that case. So obviously, one of the planned things is to do multi-threaded, like super multi-threading, like where you're multi-threading, but you're doing multiple numbers in a single data type. So instead of using 32 bits and adding together 4 bytes within those bits without using it as like a whole thing. It's like to do 8-bit addition. Now, to check that is kind of going to be a pain. Let me get out the drawing board again. I did discuss it, but I need to refresh my mind to get the maximum efficiency out of my brain cells. So you have like 0A, 0B, 0C, 1, 2 maybe. Like something like that. These are all bytes. Oh, so you can only do... Technically, you can do 8 numbers, or 8 times 4 times 8, but it's technically just, byte. But if you did 4-bit addition, that's even better, because then I'd have even more. It'd be literally 8 times 8 at that point. Just saying, like, if you can get it down to, like, where you're using the least amount of bits as possible to do the most amount of work, that's, like, obviously amazing. But yeah, we have these. These will go onto my, these will go to my CPU core. And if I have, like, X12, then I multiply my, 12 CPU cores by, this number, because that equals 32, which essentially is saying that I can divide 32 by, what was it again? It was like, what was it, 4? No, 8. I mean, I guess it is divisible by 4. You get the same thing, but yeah, you can divide by 8, which 8 goes into that. Oh, wait, it just goes right into that 4 times. So we know the answer is 4, and that gives us 0 down there because we do long addition, and then it gives us a 4. So then we have times 4, which gives us 48 cores, but it's not cores, it's now V core with V threading. Now, there's some issues with this concept because, that's all swell, but there's some issues, right? Because you can't just handle the data type we put those in as its original type. It's now a new data type. So uint equals 32 bits. Then the data type that we're going to put into uint is a ubyte, and that is 8 bits. 8 bits. So now you can see that that's where the 4x number comes from. However, the problem is this no longer this is beautiful. This is a work of art. Behaves. Hold on. Excuse my text box, but behaves. Oh, son of a. How dare you? As uint. It no longer is going to behave as a uint. It's going to have to behave as. It needs to behave as 4 ubytes. And byte is 255, integer limit uint is big number. Uint yeah, big number. Un grand nombre or some shit. I fucking don't speak French. So yeah, that's where things are interesting, right? So we have our like uints, which is 32 bits, but it's going to contain these 8 of those. So how do you handle that then? What is the idea? The idea is simple. We're gonna take the 32 bytes, or 32, yeah, 4. We're gonna take the bytes, handle them as U bytes. We need to create rules that handle them. So 18, A2, C3, D4. I guess you could technically check if the sum of these numbers is valid before you do it. So you would split them up, break it down into these, okay? Break it into those, and compare those two numbers. Or there could be another way we handle these numbers to break them down effectively. But like, for example, like if you could technically check that if we add these two numbers, like that would defeat the purpose. The second we start adding these individual pairs together and doing it sequentially, it will slow down the process. We need an algorithm that is able to detect the entire equation, not just pull the values. Maybe initialization of the process before we even get started, it checks these numbers, like before we can even add them together from the register. That's what we need to do, is have these be like checked, like C4 and then F6 and E, which is a big number again. Actually, not that big of a number, probably. Hopefully, it is. I mean, FF is the highest of those. I mean, checking each number, that takes time. But, well, actually, no. Here's some other things to create rules about. So our first rule is we cannot individually check the bytes. So we have to check the whole. We must check uint, or yes, uint, like a normal human, and put it all lowercase. So that's one. The second one, we cannot use different threads for the task because the program, or because the others cores are booked. The reason they are booked is because they're also doing this with different numbers, which means they're busy. The other threads are handling other numbers So the way you would do this efficiently would then be to check the uint, which we've already determined is like the thing we have to do. We have to check them as a whole. So what is a common thing that we can check in all of these? Like, what is something... We gotta start looking for a property or some kind of way we can check these. Okay, save. We gotta come up with some common way we can check these to handle them, which is kind of questionable. Like, my brain's like, well, there's really not much choices for this. If we handle them as a uint, you run the risk of not actually checking them. That's the problem that creates it. Because it behaves as a uint, but we must check uint. How do we must behave as 4 bytes. How do we get to that? That's the real question mark of everything we've done, is this question mark. That's the question mark right there, the big question. Because I don't have a good answer to that. Alright, so we're gonna work on initializing 4 different bytes into the register, or actually creating a U. I think our first goal will be creating a U byte instruction that assembles a U byte with 4 different numbers in it. So, or yes, a uint with 4 different U bytes. So in case 0x2, 0x02, or case 2, we'll copy and paste that same code, and then copy pasta code right here. Copy pasta coder. And then we need to handle attempting... this is a register initialization. Reg U bytes, I guess. I mean, and then this is a register for U byte. And we have to put an underscore there, so that way it's pretty verbose. I want to put an underscore there. We want to put four of those. And you can't do that iterating it. That's not how we're going to do it. It's just going to be as simple as we're going to get this address. We're going to pull increment potentially within this code here. We might increment the I value to do it. Because in theory, we could reasonably pull the next address by just incrementing the lines of code by 4. So attempting a register for U byte, then it's going to get the bin, and then it's going to... The uint for the address is going to be the same, but it's not going to grab that. Instead, it's going to call another function that's going to actually allow it to put in that register. Well, it's going to call the same functions. It's going to append, or no, not append, because it's not like a string. It's not going to... No, that won't work. But it's going to grab the next 4 and assign them to an array? No, it can't do that. It needs to grab the entirety of the next section. So it needs to increment the engine state, where is it at? Right here, and the I at the same time. And I hope this doesn't break anything. It definitely could. So it gets the address, and then it's going to increment the state. And it's going to do that right here. Plus I. So that means if you have a loop that handles this function, this instruction, your loop will break. But we could also just say that it sets these to zeros. That will mean your code won't execute again in the future. Or it tells it to skip that. Well, that's basically what it does here. It tells it skip. If you want a loop, you have to make your own loop. You cannot use the regular initialization functions like this I here. You cannot use this iterator from my loop to make a loop. If you want a loop, you're just going to have to build it off of the original bytecode I'm making. Very original bytecode, yes. That's terrible. But it will do that, and then it's going to put engine registers address equals that, and the engine state will not, I don't think we need to increment engine state, because it will hit that plus I. This, bad. That's a lot of code to execute. It's going to hit that plus I, and it's going to go, okay, got it. Plus I think we can literally just say that the engine address just equals that line that it grabs out of there. Or the engine equals that at that address. So that basically means that now when we call that from code, which will be the 0x02, effectively we need to now figure out what we're doing with this. So here it's going to be 1102 0000. Actually, the address is still specific to the program, and once it reaches the end of the program, I want to also get an idea of these registers anyway. That should be 2, that should be 3. The next one will be the 0. No, those have to be 1, but the address is wrong in those because it's putting it to the same address. Yes, these have to be 1. This needs to be 2. That needs to be a 02 here for the address. That needs to be a 02 there for the address. And then we need a 03. I mean, technically, yeah, I could put it at 23. That'd be fine. 00. And then, we're going to put in the number C3 FF D4 R. No, R is not a value. 5F. Is 5F actually valid? Or not? Not valid? Oh, it's an underscore. Bro, my text file looks crazy. Be like, what the hell is that text, bro? Why is it that letter? Who is that? I once had a friend and he was German and he was like, yeah, this funny looking U with a dot is funny. It's not a smiley face. Please don't call it a smiley face. I was like, okay. What a very serious guy. Very serious fellow. And... what? So we do that, and it doesn't care about the next engine state. So the first engine state puts a register there, register there. Is there just a default case that just says all of this? Does it not write engine when it breaks and goes, yeah, right engine? Right engine, bro. You know what, it's fine. I'll just put right engine dot registers. It doesn't even write those? Write bin for engine state. So I guess it never breaks that loop without the, or with catching the exceptions? Or do they not have write bin and write? What's science. There's a lot of stuff going on there. There's a lot of stuff going on here. There's a lot to consider with this code. Oh, but it's a lot to consider. Oh my god. Well, we're looking at the engine registers. They should be writing the engine belt registers, and then the struct should still exist at that point. And I think if we just write the engine state and engine registers at the end, that'll be fine. I suppose that will be fine. Yeah, and then it appends registers to it, and then, oh god. But that's wrong. Why is that wrong? Well, let's figure that out. First, it has a register 255. Does it? Can we check the current state of that? So it's doing write ln for that. We'll copy this write ln and we'll check the get bin, which is 8 to 8. We'll write ADR. And then that's correct, I think. Address. And then address 0 on both. Hex. Did I save this? Did not save it. That's why it's broken. Oh, it caught an exception. Index 0 is out of bounds for an array length of 0. Damn, that's like not even an exception I programmed. Fish bitwise .d 56. Index 0 is out of bounds for an array length of 0. So that's in here. 56. Instruct equals output, and it puts instruct out there for an array length of 0. What instruction handles that? Oh. What happened is it attempted to grab something that doesn't exist. For example, this. It probably attempted to grab it, but didn't know where to grab it from. But actually, so in the first engine state, it identifies that it needs to perform an 8-bit operation, attempting register ubyte, and it then assigns that there on the register, and then it continues down, and at address 2 assigns the next one, which is weird because the first one assigns to address 0 for whatever fucking reason that is. Let's check that. I mean, I don't know, but assigns to that. Then this one here is correct. Something to assign it address 1, but there's a 1 here, so it's going to address the next address over. That's 0, 0. This is 0, 2, which makes sense. But it's attempting to assign another value to that. So address 1. Same kind of thing, but that's the correct address now. That one needs to have the address in there. I don't really like including debug lines, but it's kind of an essential thing when we're working with the program that doesn't want to do what we want it to do. Technically, we could save on lines by just having these get integrated into the rest of the program. For example, here we put that and paste that and put a space before that. That would be the most effective way to do it. And then do the same thing on the next one. Copy that and put it into here. Now we have our ADRs for our addresses. Paste. Semicolon, and that should be good. All right, let's see if we got it better this time. So yeah, that's better. Address 0. I don't even need to check these anymore, do I? Yeah, they're initializing correctly. I want to see that the 32-bit number is on the correct one. That one now needs to change from 03 to 02. And it needs to not accept that second set of zeros. In theory, yeah, you could have more numbers here, have bigger instructions, but that'll be safe for like 32-bit ones. Now, I think an issue that it might be having is that it's checking that 0. So when it polls the next engine state or attempts to poll that, it shouldn't update engine state right away because engine state is updated at the very beginning and we're in the middle of it, so that's not an issue, right? Yeah, it does at the beginning. But what it should do is fetch the next address here and increment that, so when it does get there, it's like, skip this engine state. It's not an engine state, it's actually just a value. You do the same thing with, like, if you have other, like, multiple different addresses you were going to add all at the same time, you would just increment the state and then use the get or fetch 32 bits. And then that's probably going to be my most used one, honestly, is fetching 32 bits. Be like, oh, I need to fetch 32 bits. Problem is that the index 0 is out of range, is out of bounds for an array length of 0. So when that happens, it's throwing the exception at attempting the reg for ubyte. So it succeeds there, but it fails somewhere else. It also doesn't append it to the correct place. check it again. Address 2? Oh, okay. That's good. Got the address 2 correct. Index 0 is out of bounds for an array length of 0. Oh, I think it's just trying to grab the next number. So yeah, it's just a problem with the fetch byte or fetch bit. Well, I guess I now can put it in a 0, 0, insert 0, 0. So now we can actually try to add in some mathematical stuff, or attempt to make, yeah, we'll attempt to add the a 4-bit math operation. So we'll have a case 02, which will be for the math stuff. Or do I really want to check multiple different ones? I could check it all in this thing. Well, I think it might be faster to check in different case layers. Alright, so there's my case, which has no purpose being there, but raise it up a bit. Case 0x02, which will be a second case. So if we receive a 2, we know that's going to be the math functions. For example, it would start off as 1, 2 in that first byte. Clearly we can get rid of a lot of this. A lot of this is just shit we don't need yet. But this will be pretty much, math will be stored in the 0x02. Let's see. 0x02. How are we going to do it? We're going to take... what are we doing, though? What is the math we're handling? Well, let's just handle 2-number addition. For example, if we have... the instruction is 0x01, which should be like... Alright, the next 2 numbers, or... it's going to take 2 addresses that are on the registers. Okay, so we're going to take an address 1 and an address 2. We're going to add them together. Should be pretty simple. So yeah, we're going to enter 1, 2, 0, 1, and then we have our 2 addresses, which are going to be 0, 0, and 0, 1. That's our first set of addresses, and it should output it into 0, 3, or 0, 4, or something like that. We then need to be able to specify another address that it goes to. The problem with this is that we have to specify it within that. Addresses can't be stored within 4 bits. So with 4 bits, we can only store up to 15 values. So that means that, obviously, technically it's 16 if you include 0. So yes, 16 values in that amount. That's bad. We can't do that, and we just can't do that. It's just what it is. So like, that means that we need a way of determining what register to put it on. Either it needs to go onto a temporary register, or it needs to go to the current register. But it needs to be one that the user specifies. That's kind of an issue, because we have 0, 0 and 0, 1 already taken. if we take two registers and add them the target register. Instead, we take this value here and use that as the actual index for the final value. It basically is saying we're not taking a slice of these, we're just going to override it anyway. So the original value for the first number in addition is going to just be disappearing. But let's take a note of what our functions even do anyway. So here we load two registers. I'll go ahead and put in like comments for documentation purposes. Loads register. And then case 02 is going to be loads vcore 4x register for vcore tm. And then we have to have this one, register function or register instructions. And then we'll create, this one's gonna be called arithmetic. This one will be called add registers. Actually, we'll just give an example of how it's used. Add A plus B equals A. Or A equals A plus B. That's the addition that it does. Technically, you might want to C equals A plus B, but I'll make that later. I'll come up with a clever way of doing it. However, this does really handle all of that register usage. Because really, if the register usage has to be handled by you, that fucking sucks. Why did I want that? I don't want that. I don't want to handle the registers. But yeah, that works. Yeah, that's fine. Okay. So now that will basically say how, that defines how my things work. Those are register instructions. Oh man, I can't think of doing using 8 vcores. The 8 vcores, or no, the 4 vcores to do multiplication. If you don't know the vcores, I've already discussed it like twice in the stream, and I don't need to discuss it again. It's just a really stupid way of multiplying our cores by creating virtual ones. Basically creating virtual 8-bit cores. I mean, it's also based on a concept that is from NPUs, so like node processing units have something like that. Although I can't really elaborate because I read about it one time and then I haven't really read about it again. So that's something to note, is that they use something like that where they can actually handle a lot more per core because they handle it in a different data type. That's my idea, at least, is to handle one data type as another, use 4 U bytes in a uint, and then go from there and try to add them somehow. It's like basically compressing your RAM, but instead it's compressing your functions, instructions. Like how the instruction is 0 is that number 0100, which is supposed to be 8. I think that is. Ooh, let's see. Right, let's get back to what we're actually trying to do. So we're gonna take. How are we gonna do this? You've loaded. All right, so you're gonna take the. You've gotten to this point, then you have that uint address A. Oh fuck, I fucked it up. Copy. Paste. Uint address A underscore A. Oh no. Uint A equals bin.getEngineState. Paste. And then uint B equals bin.getEngineState 0 with a width of 8. And then you need to reload the register after we write the what it's doing also. Paste. But he just went off for some reason. Like, that's weird to me. Never mind. Attempting register add. So we're gonna take one of these and we're gonna go ahead and do copy, paste. So then the register also needs to be created as well. Pretty much the same thing almost. Paste. And then we have A, comma, plus, comma, B. Then we do that. We save it now. So we do engine, registers, address. But those aren't going to be get engine states. Those are going to be the address is the get engine state. So the address has to be that. So we have to do a get bin. Okay, that is correct. But it needs to be the engine.registers contains that. Okay. Engine.registers. And then this is the address. That function gives us the address for engine.registers. Don't ask me how that works, but it's going to. I don't know how putting a function inside of that's going to do a good thing. It's probably going to do a terrible thing. Ugh. Oh wait, that's what it is. It's this get bin engine state. Also need to put a equals and a comma there. How well this works all depends on our luck. Probably won't work. Will it work? Won't it work? Yeah, so that does everything. All in one line. Hopefully. And so yes, you will be able to create a save state of that final struct at the end. That's one of the ideas, is that save state. Because when you save the state, it will allow you to re-go back to what you were doing before. It's a genius idea. Although it's also fucking stupid. Because if it crashes and then saves the state, also bad. So it has to crash without saving that state. So there's that too. Copy this. Actually, the engine.registers address equals not fetch 32, but paste, and literally just take A plus B. Pretty sure that's how that works. A plus B. But if that does it in a decimal format, no bueno. Pretty sure of that. It needs to be done as 2 U bytes and then casted to a U int, but is that even possible? Probably not, because it doesn't store U byte. I mean, A plus B should be the same. Yeah, I mean, it should be the same. Let's give it a shot. Let's give it a shot. Oh. Address? Oops. My bad. I mean... A. So it takes 2 addresses, and that's the 2 numbers it's gonna do. The first one is the target address, by the way. Paste. And where does it screw up? It doesn't have a parameter there. That is some dense code. Registers.address basically needs the same thing. There's a lot of get addressing. Attempting to add, and it gave a 450 number. That's correct. You take those 2, add them together, you will get 450, but that is no longer an 8-bit number, so it has that's not an 8-bit anymore, unfortunately, because we loaded those with let's load them with 1 and 2 instead. So that will be me going into here and instead just putting a 0 1 and a 0 1 and getting a 2 out. One plus 1 equals 2. Look at that. 2 equals 1 plus 1. That's genius. It's like a artificial intelligence, basically, at this point. Damn, Mark Zuckerberg has nothing on this. I finally beat him with my new technology. Even though it's breaking because it doesn't have any exceptions to handle well, I guess we'd throw a 1 0 0 0 0 0 0, save it, run it, and receive a nothing at the end. Because type 1 would throw the exception. No, wouldn't it be like you just do a 1 0 1 1? 0, 0, 1. Like you do 1, 1. Like 1, 1. Like you know what I mean? Like a 1 and a 1. Okay, I'm pretty sure that would throw an exception as well. I mean, if you threw another 1 in there, it would just reset it to 0. Oh man, this is working really good actually. I'm impressed right now. Anyway, I'd like to thank you all for watching. I'll see you all next time, and goodbye. I'm about done with today's episode. Thank you all.